Good evening, students. Yesterday we started the discussion of inserting the symbols into the symbol table using an SDT. So we will complete it. If you see, we can't just confuse in an SDT that the SDT in the right hand side should directly project the production given. For example, here if you see, D is derived as T and L. Okay, so we can't say in the SDT it should be like D should take the value from T and L. It's not like that. So the SDT is defined for the purpose of us. So what we need to implement, that we are giving it as the SDT. So we can't say what the production does in the given grammar, that should be written in the SDT, but we can make the productions execute along with some additional actions through SDT, right? So whatever we have told this grammar to perform along with this SDT is only performed. So no confusion in that. SDT actions are different over the productions. It is related, but we can't say what the production does, that should be implemented in SDT also. So based on the SDT type of definition of the SDT, we can categorize that into S attributed one or an L attributed one. So as you know, S attributed one is synthesized attribute where a parent takes its value from its children, right? Whereas inherited one is the one where the children will take its value from its parent and also from its sibling. But when it's come to L attributed SDT, it is a part of inherited one where the attribute will take its value only from its left side of the given production, either from its parent or from its left sibling. That was L attributed one. So this that is the thing we have to note. So another important thing we have to know is, when a variable or an element is S attributed one, synthesized attribute, its value is evaluated at the last time it is visited in the parse tree. Whereas if a attribute is an inherited one, it is evaluated at the first time when it is visited in the parse tree. So that too we have to keep in mind. So now let us see the execution of this SDT. Suppose we are considering the example as int x, y, z. We are having a declaration. From this declaration we have to create a symbol table such that what type are x, y and z. X is an integer type, y is an integer type, z is an integer type. That is the purpose of this symbol table. Fine. Now basically what does this grammar does? It is a declaration of type and list of attributes. For example, the type and the list of attribute. So how can be this list? This list can be either a single attribute, that is sometime we give only int x, right? Or it can be a list of attributes. So here we are having list of attributes. So you don't confuse between individual list ID. Don't confuse like this. It is list of attributes. Either the declaration is a list of attribute or a single attribute. So here we are having a list of attribute. So declaration can be a type and a list of attribute, and the list can be a single attribute or a list of attribute. Okay, and the type can be integer or a character. This is what this grammar will define. So along with that, what we give in the SDT, That is the thing we have to analyze. First we will check what type of SDT it is. So if you see L dot in equal to T dot type. So L dot in is at the rightmost end of the given production. It is taking its value from its left sibling. So as you know, it is an L attributed one and inherited. Fine, and it is also inherited, that we have to remember. Similarly, when you go for the second production, T derives int. Here what we give, T dot type left hand side is taking its value from its right hand side, children, int or character. So these two are synthesized attributes, right? S attributed or synthesized one. And when we go for this, we are just for differentiating the left side L and the right side L. I am giving a derivative L1, but it is not very big different. The variable is not different. It is left hand side and this is right hand side. Just for denoting, we are giving a derivative. So now here what is happening, L1 dot in, the input of L1 is the value from the left hand side. As you know, the children is taking its value from its parent. So again this is an inherited attribute. Okay, inherited attribute and also L attributed one. So overall this SDT is an L attributed SDT that we have to define. So now before implementing this SDT, we have to construct the parse tree for this grammar. So if considering the input statement as int xyz, how we can construct? So we want int xyz. So we start from declaration. So declaration can be either a type or a list. And here the list is not a single attribute, right? It is not only int x, it is int xyz. So again there is the list. So you have to take this third production. So the list is nothing but another list and id, and this one can be z. This is z.